Hello friends, in this class, let's discuss everything about the binomial expansion. It's going to be a long way because we're going to break it into part, just the way we have been doing it. And I'll take it one part. Please, don't enter the next part until you understand the previous part. Do you understand? First of all, what's the binomial expansion? The binomial expansion is simply a way of expanding a binomial expression that is raised to a power. When we expand a binomial expansion that is raised to a power, we are therefore doing what we call binomial expansion. It's a way of expanding a binomial expression that is raised to a power. A way of expanding a binomial expression raised to a power is called a binomial expansion. Get the rule. For the last time, it is a way of expounding a binomial expression that is raised to a power. Now, let's say, for example, we have an expression x plus y raised to power n. How do we solve this? This is very simple. As the power of x, listen to me, as the power of x decreases, the power of y increases. Now, I like explaining it like this. Let's say, for example, you meet a guy, one guy does not have, and another guy has. But you decide to go for the guy that has. And that guy that does not have start to build. And the one that has start to waste. You observe that the other guy that started to build will meet that guy that is wasting. And it will exceed. So, this is named as saying x raised to power n, y raised to power 0. Plus x raised to power n minus 1, y raised to power 1. Plus, what can you see? As the power of x decreases, the power of y increases. S raised to power n minus 2. You can see that y will be raised to power 2. Plus s raised to power n minus 3. Y will be raised to power 3. Dot s raised to power n minus r, y raised to power r, plus dot x raised to power 0, y raised to power what? N. You can see it as the power of x. The power of x was s raised to power n, y was 0. S was s raised to power n minus 1. Subtracted 1 from the power, y increases by 1. S raised to power n minus 2, y increased by 2. S raised to power of n minus 3, y increased by 3. S raised to power n minus r. R means we don't know where r means the term they give us, the infinite term. When we get to that infinite term, we're going to stop. So s raised to power n minus r, y raised to power bros. X now is raised to power 0. Shabi, y raised to power what? N. Do you understand? This is simply what we call the binomial expansion. We have not got to binomial theory. This is just normal expansion, not even binomial. How do we do normal expansion? As the power of x decreases, the power of y increases. As the power of x decreases, the power of y increases. Let's take that again for the last time. Look at this. I'm just writing the same thing. S plus y raised to power n. This now becomes s raised to power n, y raised to power 0. So y started from 0, s started from n, plus s raised to power n will be reduced by 1, y will be increased by 1, plus s raised to power n minus 2, y 2, plus s raised to power n minus 3, y 3, plus dot s raised to power n minus r, y r, plus dot s raised to power 0, y raised to power n. So this is what we call the binomial expansion. For the last time, what's binomial expansion? It is simply a way of expanding a binomial expression that is raised to a power. Do you understand? And we said that what's our part called? As the power of x decreases, the power of y increases. Do you understand that? Now, if you say you understand that, what are the two ways of solving? This is what we said. We give s raised to power n, y raised to power 0, plus s raised to power n minus 1 raised to power 1, plus s raised to power n minus y raised to power 2, plus n raised to power n minus y raised to power 10, plus s raised to power n minus r, plus y raised to power r, plus s raised to power n, s raised to power 0, y raised to power what? N. And we gave the rule. What's the rule? We said as the power of s decreases, the power of y increases until the maximum power of the expression is what is attained. Do you understand? So that's just the trick. Now, If you now say you understand that there are two ways, practical ways of solving the binomial expansion.
Hold on a bit. As far as 100 level is concerned, right, for both first and second semester, your complete series of classes, including your practicals, everything from beginning to the end is in the LearnLift app. All you have to do is just march down to your Play Store or App Store and download the LearnLift app, and then you're going to have access to every singular class. So just move down to tertiary, click on tertiary plan, where you are going to see all your classes as far as your 100 level is concerned. And guess what? Your video lessons are there, your CBT is there, you have access to your past questions, you have access to your notes. Very, very important. Man, this semester, you must do well. Anyway, let's proceed quickly as we march down to our class and continue our class. Enjoy.
Number one, we're able to call the Pascal triangle, and number two, we're able to call the binomial theory. So how do we find the binomial expansion? Either we are solving it through the Pascal triangle, or we are solving it through the binomial theory. Do you understand that? Now, if you say you understand that, let's start with the first guy, the Pascal. Are you with me? In Pascal triangle, what we are trying to do is that, number one, we are trying to get the coefficient of each term of the binomial expression. We are trying to get the coefficient of each term. I'm going to be saying a lot here. So we are trying to get the coefficient of each term of the binomial expression. And number two, each member in a line is obtained by adding the two adjacent members in the line above. Each member in a line is obtained by adding two adjacent numbers in the line above. I'm going to explain this. Leave all these notes talking. So take note of this second statement. Let's go to the Pascal triangle. First, let me give some parameters. We have n. For example, now you know what n is. We said that if we have x plus y raised to by n, so you should know that this n here you see is the power. So that's the Pascal triangle and that's the coefficient. Let's start when the power was 0. So let's like saying x plus y raised to power 0. What? Remember that I said there are two ways. Either you are solving it with the Pascal and binomial gives us their coefficients, but the rule still holds. As y increases, x decreases. That's the rule. But to get the coefficient, you know coefficient, I mean the number standing close to each number, we need either the Pascal triangle or the binomial theorem. So let's see Pascal triangle, what will give. Let's say, for example, n is 0. Are you with me? So let's say n is 0. The Pascal triangle is 1. The sum of the coefficient is what? Is 1. Now, hold on, you're going to catch it. But just first of all, follow me. Let's say that the triangle is also what of if n is 1. If n is 1, it's going to give us 1, 1. How do you get? Yeah, this one is the sum. Take note. This is sum. Like sum. Sum of the coefficient. So, now, hold on now. Let me explain. Take note that in this triangle, you see 1 must always start, 1 must always end. So, now. And how do we get 2 here? This 2 is 1 plus 1. Now, you understand it now from number 3. Let's go. What of if the power is 2? The first thing is that 1 will start. So, I'll bring this 1 down. 1. Now, this 1 plus 1. 1 plus this 1. What can you see? 1 plus 1 will give me 2. 1 must always end because we say 1 must start. So, I'll bring this 1 now down. 1. How did I get it? First of all, 1 must start, 1 must end. So I bring 1. 1 starts. 1 plus 1, 2. I bring the other 1 down. What's 1 plus 2? 3. If you sum this, 1 plus 2, 3. 3 plus 1, 4. So what's the last guy there? The last guy is 4. Do you understand? Now let's do for 3. What we start? 1. Right? 1 plus this 2. What's 1 plus 2? 3. 2 plus 1, 3. This 1 will come down 1. And what's the total there? The total will give you what? 8. 1 must start, 1 must end. And we said that each number is gotten by adding the 2 number of the above of the adjacent line above. So let's do for 4 now. What we start? 1 we start. So this 1 now plus 3, 4. 3 plus 3, that's 3 plus 3, that's 6. 3 plus 1, 4. 1 must end. And that will give me what? If you total it, you get 16. I'll take you back to how to remember this triangle. Just follow me. We'll do up to 5. Only you can do from 5, 6 above. Now let's do for 5. What we start? 1, we always, this 1 we start 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. 1 will always end. And what's the total? 1 plus 5 plus, if you total that, you get what? 32. Now hold on. I want to deduce two things from here. The first thing I want to deduce first is that when it was 0, how many 10? 1 10. How do you know it is 1? Look at when it was 1, when the power is 1. Remember, I've said this n is power now. How many 10 do we have? 1, 2. When it was 2, how many 10 do we have? 1, 2, 3. When it was 3, we have 4 10. Look at it. 1, 2, 3, 4. When it was 4, we have 5 10. 1, 2, 3, 4, 5. So when it was 5, we have 6 10. Let's count. 1, 2, 3, 4, 5, 6. It means that the number of 10 of a binomial expansion is equal to n, which is the power plus 1. So here was 2. So what's the number of 10? N plus 1, that's 3. You can see that it has 3 terms here. So what's the number for number? So here is 5. How many terms we have? 1, 2, 3, 4. So if it's 6, we're going to have 7 terms. Do you understand? Now, how do we now get this sum of coefficient? Because it's a constant pass question. What's the sum of the coefficient? What's the sum of the coefficient? What's the sum of the coefficient? This is my bad code. To get sum of coefficient, sum of coefficient. The form the bad code is 2 raised to power n. What I call the bad code, 2 raised to power n. So here now, when n is 2, that's 2 raised to power 2. What do you have? 4. Trace it, you have 4. Did I count it? I just my bad code. When n is 3, that becomes 2 raised to power 3. What's 2 raised to power 3? 8. When n is 4, 2 raised to power 4, that's 16. 2 raised to power. So what's the bad code? 2 raised to. So two things here to hold. Number of terms is equal to n plus 1, and sum of coefficients is equal to 2 raised to power n. From Pascal, do you understand? Very simple. You can pause it, watch it as I move further to past question. So we capture that, say note two things. What are the two things to note? Number of terms is equal to what? N plus 1. And number 2, we say that the sum of Pascal, what's the formula for sum of Pascal? 2 raised to power n. So that's the summary we got from that word table. Now, let's go straight to past question. We're told that the number of terms of an expression, what was the expression? The expression was giving x minus 70 raised to power 8. You see, what's the number of terms? Normally, an idiot is supposed to expand all of them. After expanding, you now start to count them. If I'm in the exam, I will expand. Do you know how you expand to 80 before you now start to count? I'll just go straight. How would I go straight? I know the number of 10. What formula for number of 10? N plus 1. So what's the n there now? 80. 80 plus 1 is equal to what? 81. What option is that? Option C. I'm done. What's the number of 10? N plus 1. What's the number of 10 terms? N plus 1. Now, the question says, find the sum of Pascal coefficient when n is 4. Find the sum of Pascal. Normally, you're supposed to get, what are the Pascal coefficient when n is 4? We're going to get 1, 4, 6, 4, 1. You know, when n is 4, you have 5. Now, let's count. 1, 2, 3, 4, 5. So, if you total this, you're supposed to have 4 plus 6, 10. 10 plus 1, 11. 11 plus 4, 15. 15 plus 1, 16. I won't do this rubbish, but it will take time. What's my formula for number of 10? Number of 10 is equal to 2 raised to power n. That becomes 2 raised to power 4. What's 2 raised to power 4? That's 16. Grab your calculator and press that. 2 raised to power 4 is equal to 16. That's formula for number of 10. Very good. Very good. That's some form of terms. Now, another question says, find the sum of Pascal coefficient when n is what? Is equal to 3. Just tell them 2 raised to power n, which is 2 raised to power 3. What's 2 raised to power 3? That's 2 times 2 times 2, which is equal to what? 8. Do you understand that? Very, very, very simple. Now, we're not supposed to find, using Pascal expansion, expand this. We're going to do this in our next class because it needs a separate explanation. I'll see you in that class. I remember myself, sir, and peace out.
Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.